Hi again. So for today, we are going to have the systems of linear equations. Beginning with the introduction to systems of linear equations. Now, what are the objectives for the lesson? So you should be able to recognize a linear equation in n variables, find the parametric representation of a solution set, determine whether a system of linear equations is consistent or inconsistent, and to use back substitution and Gaussian elimination to solve a system of linear equation. Now, what is a linear equation in n variables? A linear equation in n variables x sub 1, x sub 2, x sub 3 up to x sub n has the form of a sub 1, x sub 1 plus a sub 2, x sub 2 plus a sub 3, x sub 3 plus dot 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 plus a sub n, x sub n equals b, wherein a sub 1, a sub 2, a sub 3 up to a sub n are coefficients of the variables and which are real numbers. B is a constant term and is also a real number. We will refer to a sub 1 as the leading coefficient and x sub 1 as the leading variable. Now we have here in example 1, several examples of linear equation as well as examples of nonlinear equation. We see here that 3x plus 2y equals 7, 1/2 x plus y minus pi z equals the square root of 2, sine pi times x sub 1 minus 4 times x sub 2 equals e squared are all linear equation, primarily because the unknown variables x and y as well as x, y, z here are all first degree. They're all first degree. Now, in the next set of examples, we will have here nonlinear equation. So we will have x times y plus z is equal to 2 is nonlinear because we have a product of two variables. For b, which is e raised to x minus 2y equals 4, is nonlinear because we will have the transcendental function of x, which is exponential. And we will have sine x sub 1 plus 2x sub 2 minus 3x sub 3 equal to 0 is also nonlinear because we will have the transcendental function, particularly trigonometric function of x sub 1. So meaning whenever we will have a product of two variables, whenever we will have transcendental functions of the unknown variables, the equation becomes nonlinear. Now, what are solutions and solution sets? A solution of a linear equation in n variables is a sequence of n real numbers s sub 1, s sub 2, s sub 3 up to s sub n that satisfy the equation when you substitute these values for x sub 1, x sub 2, x sub 3, and x sub n into the equation. The set of all solutions of a linear equation is its solution set. To describe the entire solution set of a linear equation, we are going to use parametric representation. Now, in example 3, we are going to have the parametric representation of a solution set. So we have here solve the linear equation 3x plus 2y minus z equals 3. Now we only have one equation to solve for three unknowns. So in order to express the solution, we can use y and z as free variables so that x can be expressed in terms of y and z. So by doing that, so let's say I multiply the equation by both sides by 1/3. I will have x is equivalent to 1 minus 2/3 y plus 1/3 z. Now, since y and z are also unknowns, and we're going to have them as free variables, we can now use parameters for y as well as for z. So let's say let y be s and z be equal to t, where s and t are real numbers. Then the expression for x becomes 1 minus 2/3 s plus 1/3 t. Y is s, z is t, and hence we can now express this in coordinate form. the solution set can be expressed in coordinate form as 1 minus 2/3 s plus 1/3 t for the first coordinate, which is of x. And since y is s and z is equivalent to t, so this will be the solution set for the given equation. To find one particular solution, we can assign a value for s and t. So since we know that y is s and s is any real number, t is also any real number. Now, if we say let s be equal to 0 and t is equal to 0, then the the particular solution will be 1, 0, and 0. Now, we can use other values for s and t and simply substitute it in the expression for x to come up with one particular solution. Now, okay, so for the first lesson, we were able to recognize how whenever an equation is linear, so we do not see any transcendental function of the unknown variable, such as a product. One of the takeaway will be a linear equation should have the variables to be first degree. There must be no product between the variables, and the variable should not appear as in transcendental form. It could be exponential, logarithmic, or trigonometric, or even hyperbolic. So whenever we do not have that, then the equation is said to be linear.